Okay, question 9 says that a box contains n marbles. They're identical except for their colour. K of them are red and the rest are green. Now, before I go any further, I'm going to think, all right, if K of them are red, then the chance of getting a red one is going to be K out of however many there are, which is N. And the chance of reaching in and getting a green one, well, how many are green? Altogether we've got N. We've got to take away the red ones, which is K. That'll give us the rest, which is green. So we've got N minus K. That tells us how many green ones there are out of how many there are altogether, which is N. So straight away I've got some ideas here of how to get into the question, and that makes all of these options look a little bit less scary to me because I've already got a couple of nice quick fractions that I've generated that will get me into the question. Now, reading on, 2 marbles are drawn randomly and they're not replaced. That's important. So if we're not putting them back, the probabilities are going to change for the second draw. The probability that they are the same colour is. Now, 2 options to start. You could think, all right, I've got 4 things that could happen. Red, green, red, green, red, green, red, green. Now, all we want is the same colour. So either 2 reds or 2 greens. So I need to work out the probability of getting here and getting here and add them together. Of course, it's quite easy to think that through without drawing the tree diagram. You might have just said, I need the probability of getting 2 reds plus the probability of getting 2 greens, because I don't mind which one happens, so I need to add them. All right, the probability of getting 2 reds. Well, what's the probability of getting the first red? I've already figured that out. It's K over N. Now, what are the chances that I get another red one after that? Well, think it through. I need to multiply. I need to not just get the first red one, I need to get the second red one as well. So I need to times them. Now, the second red one, you need to think how many reds are there. If you've already taken one red one out, and you did have K red ones, you're only going to have one less than that now, aren't you? So you're only going to have K minus 1 red ones to choose from. And how many marbles are in the box altogether at that point? Well, you've just drawn a red one out. So to get your second red one, there's 1 less. So there's not N in there anymore. There is N minus 1. Right, that's the first section done. Now, what's the probability of getting 2 greens? Well, we need to add, and we need to get 2 probabilities here and multiply them together just like we did there. Well, I know the chance of getting the first green. I've already thought that through. There's N minus K greens altogether out of N marbles altogether. Now, if I do get the first green one and I want to get another green one, I need to multiply. How many green ones are going to be left if I've already taken one? Well, if I had that many and then one got taken away, it's going to be N minus K minus 1. That's how many greens are left. And how many marbles are in there altogether with this scenario of getting 2 greens? Well, here there was N. There'll be 1 less on the next draw. So now I'm just going to multiply these together, and I've got a lot of options here to sort of see where I'm going. Now, both of these denominators are the same, which when I'm adding fractions, I need denominators to be the same. So that's looking good. Now, if I just tidy up a little bit, on this fraction here, I've got N times N minus 1, and I'm not even going to bother expanding that out to say N squared minus N, because I can see that some of these options here have that. So I'm thinking straight away, it's looking like C or D, but perhaps there's some simplifying that can help me, so I'm not going to guess just yet. Now on the top I've got K times K minus 1. Now over here, tidying up this fraction, it also has N outside of N minus 1 on the denominator, and on the top it's got all of this multiplied by all of that. So for now I'm just going to write down what to do in case I need to expand or do something else in a minute. Now when I'm adding together fractions, I keep the denominator the same, and that will be N over N minus 1. And all I need to do is add all of this to all of this. Now, having a look over here, I can see that this one looks exactly like my answer because I have K outside of K minus 1 plus all of that. So it's looking like answer D. And it turned out that there was no need for me to actually expand out or do anything more because I can see that my answer is right there, D.